The North American continent, from Precambrian to today. How did we go from a hostile, lava-filled planet to the Earth we know today that's covered in vegetation and life? Starting with the Precambrian period around 4.6 billion years ago through 543 million years ago, about 88% of Earth's geologic history, Earth was covered in a vast lava ocean and was constantly bombarded by meteorites which may have contained water. As the Earth began to cool, heavier elements and minerals like iron sank to the core, while other lighter minerals like silica rose to the surface, forming different layers. As the core began to form, Earth began to develop a magnetosphere. With this major step, the Earth was finally able to start creating an atmosphere by containing the various compounds like carbon dioxide, water vapor, and methane that were produced by volcanic outgassing. Because of radiogenic heat, the convection currents in the asthenosphere moved faster than they do today. The volcanic island arcs would be smushed together to form our first versions of continents. In addition, water began to condense and form oceans on the crust. Amino acids, nucleic acids, and different carbohydrates and lipids all began to combine into different forms that eventually produced the first living organisms. Unicellular organisms began to rapidly multiply and diversify. Some unicellular organisms, like Cyanobacteria, were photosynthetic and helped produce oxygen into the atmosphere. As continental accretion continued, the continent of Laurentia came into existence and later formed what we know now to be North America. Oxygen was slowly accumulated into the atmosphere by photosynthetic organisms. We can see this progression of oxygen in the atmosphere when looking at banded iron formations. With the atmosphere reaching a stable oxygen level, eukaryotic cells began to develop. Within the span of 2.5 billion years to 542 million years ago, Earth formed the supercontinent Rodinia and thereafter the supercontinent Pangaea. Because of the deformation of splitting apart continents, Laurentia experienced a slight rifting within itself. Then came the Cambrian explosion. With the first major transgression, the Sauk Sea spread across the early North American continent, and the earliest vertebrates, such as jawless fish, began to evolve along with many other types of invertebrates, such as trilobites, brachiopods, and archaeocyathids. During the Ordovician period, another major transgression resulted in Epiric seas. Bryozoans and shelly brachiopods dominated these seas, forming large-scale reefs. Also during this time, a divergent plate boundary widened the Iapetus Ocean and caused the outer edges of the Iapetus Plate to become subducted under Laurentia through continental oceanic convergence, resulting in the Taconic Highlands, an ancient mountain region that would have run through present-day New York. Due to continental glaciation, the seas began to regress across the continent, possibly causing a mass extinction of many marine invertebrates. And, as the ocean regressed, depressions resulting from the formation of the Taconic Highlands were able to keep the salt water in their basins. Eventually, that water evaporated, leaving behind massive evaporite deposits. Then came the Devonian period, the age of the fish. Placoderms, like Dunkleosteus, and many lobe-finned fish evolved. The significance of these lobe-finned fish is that their bones allowed for more areas for muscles to attach. This evolution allowed for Crossopterygians to use their fins to come up to land. From Crossopterygians came the evolution of labyrinthodonts, like Tiktaalik rosei. While the fish were beginning to dominate the seas and evolve, the Iapetus Ocean began to narrow until Laurasia, which was then composed of Laurentia and Baltica, converged with Gondwana, causing the formation of the Wichita Mountains to the south of Laurentia, and also causing the Appalachian Mountains to form. By the beginning of the Permian period, the supercontinent Pangaea was fully formed. Amphibians began to evolve, land animals spread, and gymnosperms became more abundant and diversified. Because of the change in ocean currents and wind patterns, the climate began to change, forming subtropical climates to the east of the Appalachian and Wichita Mountains, and desert-like environments to the west. By the end of the Permian period, Pangaea began to break apart, and more glaciers began to form, causing lower sea levels. Possibly due to the mass amounts of plate activity from forming and destroying Pangaea, the Permian experiences the greatest mass extinction recorded, wiping out 75% of land vertebrates and 96% of marine life. The Mesozoic era contained the age of the reptiles. After the Permian extinction, the life that had survived grew and evolved. For example, some pelycosaurs, which were fin-backed reptiles and who were dominant in the Permian period, evolved into dimetrodons and epicosaurs, while Thachodontia evolved into ancestral archosaurs, such as the crocodiles, pterosaurs, and eventually birds. Volcanic island arcs then attached to the western part of the North American craton. The subduction results in the Sonoma Orogeny. Cynodont therapsids, which evolved from the pelycosaurs, became extinct as they evolved into mammals. To the east, North America and Africa began to separate, resulting in block faulting and igneous activity in the Appalachian Mountains. And, as North America separated from South America, the Gulf Coast began to rise above sea level. Then, birds began to evolve. Birds are believed to have evolved from the reptiles. One key piece of evidence is the reptile Archeopteryx. Sauropods, in addition, started to dominate the land. With the oncoming of the Zuni sequence from around the late Jurassic to the early Cretaceous period, North America was flooded twice as sea levels began to rise, transforming the Sundance Sea into the Cretaceous interior seaway. By the end of the Cretaceous, angiosperms, or flowering plants, also began to develop and evolve. But then came the Cretaceous Tertiary Extinction, the event that wiped out nearly all of the dinosaurs around 65 million years ago. Some hypotheses for how or why this major extinction occurred are a large increase in volcanism and plate activity, and or possibly the impact of a massive meteorite on Earth's crust. At this time, the subduction angle from the accretion of volcanic islands to the west of early North America shifted from a low angle to a high angle, resulting in a large plutonic migration east. As well, deformations caused the development of the Laramide orogeny, which are now known as the present-day Rocky Mountains. With the extinction of the dinosaurs came the rise of the mammals in the Cenozoic era. Mammals began to diversify into monotremes, marsupials, and placentals. Primates eventually evolved into humans. With the coming of the Ice Age, many of the species that existed were large, which is possibly an evolutionary trait that they evolved to keep them warm. During the Pliocene, another extinction event occurred, leaving behind the organisms we know and see today.